Python offers a rich set of built-in data structures that are essential for organizing and managing data efficiently. In this section, we'll dive deep into strings, lists, tuples, dictionaries, sets, and arrays. Strings are sequences of characters used to represent text. They are immutable, meaning once created, they cannot be changed. Strings support various operations like getting their length, accessing individual characters or substrings using indexing and slicing, changing case, and replacing parts of the string. You can also concatenate strings using the plus operator. Lists are ordered, mutable collections of items. They can hold items of different data types and are one of the most versatile data structures in Python. Lists allow you to access elements by index, modify elements, add new elements using append or insert, remove elements using remove or del, and even slice them to get sublists. They are dynamic, meaning their size can change. Let's check your understanding of strings and lists. These are incredibly common data types. Pause the video, try to answer, and then we'll reveal the solutions. Tuples are similar to lists, but with one key difference. They are immutable. Once a tuple is created, its elements cannot be changed, added, or removed. They're defined using parentheses. Because they are immutable, tuples are often used for data that shouldn't change, like coordinates or database records. They can also be used as keys in dictionaries, which lists cannot. Dictionaries are unordered, mutable collections of key-value pairs. Each key must be unique and immutable, like strings, numbers, or tuples, while values can be of any type. Dictionaries are incredibly useful for representing structured data, similar to how real-world dictionaries store definitions for words. You access values using their corresponding keys. You can add new key-value pairs or update existing ones, and iterate through keys, values, or both. Test your understanding of tuples in dictionaries. Pause the video and try to answer. Solutions are next. Sets are unordered collections of unique items. They're useful for tasks like removing duplicates from a list, performing mathematical set operations like union and intersection. Notice how the duplicate 2 was automatically removed when the set was created. Sets are efficient for membership testing and eliminating duplicates. While Python lists are dynamic arrays, the built-in array module provides actual arrays that are more memory efficient when you need to store a large collection of homogeneous, same type, numeric data. The array module is good for performance when dealing with large datasets of numbers, but for general-purpose use, lists are more common due to their flexibility. For serious numerical computing, you typically use the NumPy library, which we'll discuss later. List comprehensions provide a concise way to create lists. They are often more readable and efficient than traditional loops for list creation. A list comprehension consists of an expression followed by a for clause and then 0 or more for or if clauses. It's a very Pythonic way to generate lists. Final quiz for data structures. Test your knowledge on sets, the array module, and lists comprehensions. Pause the video and try to answer. Solutions are next. Beyond the built-in data structures, Python's collections module provides specialized container data types that offer alternatives to general-purpose built-in data types. These are highly optimized for specific use cases. A counter is a dict subclass for counting hashable objects. It's an unordered collection where elements are stored as dictionary keys and their counts as dictionary values. It's perfect for quickly getting frequency counts of items in an iterable. A deque, a double-ended queue, is a list-like container that supports adding and removing elements from either end with approximately O to the 1 performance, unlike lists, which are O to the n for operations at the beginning. Deques are ideal for implementing queues and stacks efficiently. Let's briefly touch upon ordered dict and default dict. Order dict remembers the order in which items were inserted, while standard dictionaries in Python 3.7 Plus also maintain insertion order. Order dict has some specific methods useful in certain contexts. Default dict is incredibly useful when you want to handle missing dictionary keys gracefully by providing a default factory for their values. Time to test your knowledge of these specialized collection types. Pause the video and try to answer. Solutions are next.